Myra. Hello, Andreas. Hello, Paolo.
Hi, good afternoon, everyone.
Hello, everyone.
Hello, Mark. Hello, Marcel. Hello, Lionel.
Hi.
Am I audible?
Yes,
Yeah.
you are.
Hello.
Hello.
Hi.
I think everyone is here. Great. Perfect. Okay, so let me share my screen for now. Just 1 second. Share. There we go. Welcome everyone to our discussion panel at SBST 2022. This discussion panel is called SBST versus fuzzing, intersections and differences. As the name says, we are here to discuss the main differences between testing using evolutionary algorithms and testing using fuzzing. There are many differences, many intersections, and we're all here to unveil those. Thanks all the panelists for being here. I know that for some people the timing is not really ideal. It's morning, very early in the morning, and well, thank you for your effort being here. I'm sure this is going to be a great discussion panel. We don't have exactly like a strict panel topics that we're going to talk about. We have some topics that we're going to talk about, but the idea is that this is a discussion panel. You as panelists, you are going to drive it towards the discussions you want to have. First of all, Sebastiano, do you have something to say?
No. I will just invite each panelist to present themselves in the context of fuzzing or search base or both, what they have contributed, and then we go ahead with the conversation. That would be probably the best way to warm up the air.
Perfect.
In here.
Yeah. So, shall we start in alphabetical order? And could you please present yourself and your work on SBST and or fuzzing, please?
Alphabetical according to first name or last name?
I guess maybe we'll go in the same order as in the slides. So Andrea, Annibale, and then the rest. Whoever is the best. Maybe.
Sorry, I didn't get you. Do you want me to start? Okay, yeah. Okay, I'm getting some echo here. I hope that works. Okay, so I'm Andreas Zeller. I'm a software engineering / security researcher at the CISPA Helmholtz Institute of Information Security. We are hiring at all levels. If you're interested in having positions for PhDs, postdocs, faculty, especially at this intersection at software testing and security, please let me know. I have written mostly coordinated and written a text, the fuzzing book, in which I put together all techniques of fuzzing. And this also includes search-based software testing, which already gives you an idea of how I position the two. It's thinking of fuzzing as a rather vague term that encompasses everything that is related to test generation. And search-based software testing is a very successful, yet slightly narrow technique under this big umbrella of what we consider fuzzing and test generation.
Hello, everyone. Oh, there's a bit of echo as well. Okay. Annibale Panichella, assistant professor at Delft University of Technology. I do believe I'm probably the only one here that needs to introduce myself, as everyone is way more famous as a researcher worldwide. So I'm the mouse among the giants, but I'm very humbly happy to join the panel. I'm actually mostly working on search-based software testing, but I had some work that combined search-based part with grammar-based fuzzing. And well, compared to what Andreas Zeller, I have a slightly different view of what is what. I think I actually have the opposite view, where search-based is broader, and depending if we go for random search, then it's more toward fuzzings. But we can discuss a little bit later on this aspect. And that's it from my side, and I'll give the floor for the next panelist.
Oh, thank you very much.
I believe this is me. I'm not sure, but well, I've been working in many and varied different areas of testing. I'm not going to recap that. Various aspects of test automation and empirical studies. And I didn't know it at the time, but I've been doing, first testing for a long time. But I rarely used the term. And I should start using it. Actually, it was a bit silly on my part. I believe I agree with Andreas, his definition of fuzz testing. However, in practice, I'm not sure that's how it is being used by fuzz testing papers, though I agree with what he says. I think that creates issues and divisions among research activities and research communities that are not really justified. Thank you.
Right, thank you very much. Next one is Marcel, please.
Yes, hello. My name is Marcel Böhme. I'm a faculty member at the Max Planck Institute for Security and Privacy in Bochum in Germany, and I work in fuzzing. So I work. My group develops techniques. We develop techniques that try to find a lot of bugs and try to find these bugs faster, and try to find these bugs on a lot of machines. So this was effectiveness, efficiency, and scalability. But I'm also looking into some kind of theory that may be explaining phenomena we see in fuzzing. For instance, I'm interested in fundamental limitations. A recent paper that I published was establishing that the cost of vulnerability discovery using fuzzing is exponential. I've also looked at efficiency, like when you have a white box fuzzer and a gray box fuzzer or black box fuzzer. And when you have a white box fuzzer that is really effective and can in principle prove the absence of errors, versus a technique that simply randomly generates inputs, how do they perform against each other, and therefore explain why we see a lot of black box fuzzers and gray box fuzzers these days in industry rather than white box fuzzers. So my position on SBST versus fuzzing is that both solve the same problem. They're only different communities. I've been fortunate enough to organize a meeting at Shonan where we invited a lot of people from both communities, SBST and fuzzing, and also the symbolic execution community, and found that there is a lot of different vocabulary. I think that will be Lionel's position as well. We are investigating similar topics, but in different communities. So SBST is a lot about search and a lot about exploring different optimization techniques and applying them to the testing problem. While the fuzzing community is trying to look at performance and particularly for different program language. The SBST is often Java, we often C. And so I think we are solving the same problem, but we are different communities and we have to go together.
Next one is Mark, please.
Hello, everyone. I'm Mark Harman, and I worked on search-based software testing initially, and then formed a startup called Magica to try and commercialize it. And we were acquired by Facebook and set about deploying the Sapiens technology there. And the thing that struck me was that almost everybody in industry, both within the company and in other companies with which we worked, all referred to Sapiens as a fuzzer. And it intrigued me and got me interested in learning about fuzzing. And so I think if I summarize correctly my position, it would be as follows. So I think Andreas Zeller says SBST is a subset of fuzzing, and Annibale says fuzzing is a subset of SBST. And Lionel says, you know, we spend a lot of time discussing all this nomenclature. I think he said this on this rather excellent platform for social media interaction that you may have read yesterday. So I actually agree with all three of them. And so any student of set theory will understand my position.
All right, thank you. Next one is Myra, please.
I'm Myra Cohen, and Mark's put me in a very difficult position now. But I've been working primarily in the search-based software testing community for years, and I've worked with not just unit testing, but more at the system level, configurability, GUI testing. And I'm actually more on the opposite of Andreas, and I actually think that fuzzing is probably more of a subset of SBST. I think SBST in some ways is more general, expansive, and I think fuzzing has a more specific use case. But I do also think that there's a lot of overlap. So I'm really looking forward to today.
Brilliant, thank you. Next one is Paolo, please.
Yeah, my name is Paolo Tonella. I'm at University of Svizzera Italiana in Lugano. And actually, I think there's a big overlap. I have been working on search-based software testing for a long time. And if I compare to fuzzing, it's a little bit difficult to find the differences, what's in the complement, in the difference between the two techniques, because one could say maybe search-based is often biologically inspired, which I mean is not necessarily false of fuzzing. Search-based is optimization, but that's also something that fuzzing does. It's optimizing some reward, some feedback. One might say fuzzing is more random, but then they introduced guidance which makes it no more random. So I guess the overlap is probably more than the complement, the two complements. Still, it's true, communities are different. You read a fuzzing paper and you don't see any citation to search-based techniques and vice versa, which is sort of a pity.
All right, thank you very much, everyone, for the introduction. I already see lots of topics of discussion here, just from the introductions. And do you have anything to add, any one of you, so far? Okay. All right, so I guess we can start by maybe discussing the main differences, as Paolo already mentioned one. It's mainly biological inspired for SBST, and fuzzing, although started a little bit differently randomly, still being guided now by evolutionary algorithms. So what do you personally think are the main differences that differentiate those two techniques?
So maybe to make it easier, when you use one or the other, maybe they will make it easy to position. That will be simplified, probably, yes. The answer.
Yeah, but it's difficult to answer that question because many fuzzing questions at different steps in the fuzzing process actually use meta-heuristic search. I mean, for example, genetic algorithms are used for the process of seed retention, seeds being individuals or chromosomes in GA. And you even have techniques like particle swarm optimization that is used for mutation selection. So it's very difficult to compare those two things as if they were disjoint because a lot of fuzzing techniques make use of meta-heuristic search at some step or another. I mean, this is a problem. In fact, the problem is in the question of the panel. Since fuzzing is so general, it's basically any randomized technique for test case generation, including SBST techniques. Then how do we compare? I mean, how can the comparison make any sense? It's very difficult. I don't think the question is even makes sense. I think there is just a huge confusion coming from the fact that the two stand from two different communities, use different vocabulary, while at the same time trying to achieve the same objectives. So that's complicated.
Yeah, indeed, the this question was made intentional because the next was how to standardize what would be the right way to name fuzzy and search space then according to what you have said. So actually it was intentional.
I think Andreas has something to add.
Yes. First of all, I'd like to. I'm getting some echo here. Myra, could you turn off your microphone? Great. Thank you. Thank you very much. No, I'm still getting an echo. Okay, good. Okay. First, I'd like to say that the term fuzzing that was coined by Bart Miller late tonight. Bart Miller is a compiler person or a programming person, and therefore I would say the term fuzzing was coined by our community in the large. So it wasn't the security community that invented it. It's just the security community in the last 10 years happily adopted it because it's so effective in finding bugs. Yet there is a difference in communities of software engineering and security. You see, in security, you find bugs, and the way you find them people don't care about how they find bugs, as long as they find bugs. Well, as long as they find vulnerabilities, not any bugs. Crashes, hangs, vulnerability. And this spirit of anything goes, as long as I find bugs, okay? If I can do anything as dirty or as unsystematic as can be, as long as I find bugs in the very end, it's. And this has led to a huge explosion in creativity, which is fun. And people do anything to find bugs. That's the currency by which they are valued in the community. And if we think about search-based software testing as a technique that is based on evolution and guidance, we have, say, for instance, grammar-based fuzzing. You have a model, you have a language, you create inputs. Very effective, but you can do so without any guidance from the program. You can do so in a black box setting. Finds vulnerabilities, great. It's closer to model-based testing than to definitely. And well, we can also discuss about the relationship between model-based testing and search-based software testing, but you see that anything goes in there. Think about symbolic testing, path constraints. You back from the program, which constraints to solve. This can be a search process, this can be randomized, but it doesn't have to. You can also just throw your path conditions into a constraint solver, find a solution, and be done with it. Well, very simplified approach here. But people who do, but if all you want is to find as many bugs as possible, you don't care about such methodological decisions. Just do whatever works for you. And if things work, you get a paper out. And if they don't, if they are just nice and elegant and systematic whatsoever, you've not got a paper out of it, at least not in the security community, maybe in the software engineering community. But for me, the difference between fuzzing on one side and test generation on the other side is merely a naming of different communities. And maybe even more important, whether you test your own program, which you have knowledge and you can exercise some amount of control, which is a software engineering setting, and then typically on test generation, or whether you test someone else's program. That's actually the thing that's secure. That is the security to introduce testing third-party programs in a setting where things are as difficult as can be. You only have the binary. You not even have the binary. You have no knowledge. You have no access to developers. No source code whatsoever. That's what was new with fuzzing when Bart Miller introduced this in 1989.
All right, thank you. It's a very comprehensive description. And I think, as you mentioned, there is the security keyword that I heard a lot here. SBST usually is on the finding functional bugs, and also I've seen many papers on fuzzing testing security issues. Is that a real difference? Do we as SBST researchers test for security? And I mean, yeah. Go on.
Me? Okay. So when I did my PhD, in symbolic execution. The first paper that I published was 2014 ICSI partition-based regression verification. So symbolic execution, and so what do I do when somebody asked, "What do you do?" My friends asked me. I told them, "Well, I find bugs." So blue screens didn't really sound interesting. But now I tell my friends that I find security flaws in the supply chain, and security flaws that you are definitely going to be impacted by. Right. So my tools run at OSS Fuzz, which is fuzzing 500 open source projects, 24 hours, 7 days a week, on 25,000 machines. So I find security flaws. Sounds much more interesting. There's money in security flaws. But the problem is the same, right? Conceptually, intellectually, we are still finding bugs. So I think it's just a matter of selling that research. And but maybe I can also add to Andreas' quote unquote rant. Fuzzing, I think, is a lot more structured than it might appear to be. I think what we do though is, instead of exploring different ways of searching for an objective, right? We want to satisfy an objective in search. We are interested in performance. So how cost intensive the fitness function is, how much time you spend in computing the fitness of a certain test is something which we really care about in fuzzing, and which we have optimized. And that's why security vulnerabilities, that's why I think the drive to kind of make this applicable in industry is also something which has driven the fuzzing community.
Right, thank you.
So maybe there is anyone else wanted to join?
I think anybody, Paolo.
Okay. Can I take the lead? Sorry, Paolo. I'll take over a little bit. No, so I definitely agree with what much has been said. I think the one big difference is that obviously in fuzzing we look at the bugs. If you find the bugs, we're happy. In search-based, sometimes we also look at, for us also, the test cases. They don't find bugs can be useful. It depends if you want to give some confidence level that, for example, the system is reliable to certain type. I'm thinking about machine learning, right? If I create tests for machine learning for different counterexample, I know that the model works well with certain counterexample. This also is an important result to show that the system is robust. So the bugs matters. There's plenty of search-based technique also applied to find bugs, but then let's say the test case, they do not find bugs actually also useful in many contexts. We can give level of not guarantees, but confidence that the system is robust enough. Although to be honest, I have a slightly different thing I introduced in the introduction, and I think probably Myra agrees with me. I see actually the setting is in a different way, right? So in search-based, in theory, we don't need to have a fitness function. We don't need to use evolutionary algorithm. So, well, Mark, you define it, but search means we use optimization, whatever that means. And that can be random search, that can be evolutionary algorithm. And the fitness function can be extremely expensive, very well suited to the code, or could be a bit more gross grained level. It doesn't matter. But to me, at least, it's still search-based. And then depends on how much, let's say, guidance we want to introduce. We go toward what we call now the search-based, but then obviously as an overhead for that. And then if you want to go like less heavy computation, then we go for fuzzing. But I can tell, at least looking at the paper lately, also in the top venues, really it's a really confusing understanding when the draw lines is. I'm not making any name, but just to make an example, there is a paper I've read in ICSI 2020 where they called this is fuzzing, but at the end we're using many objective genetic algorithm. They will use approach level and branch distances, which is the same thing we use for search-based. And it was rebranded with the entire paragraph. This is not search-based. This is fuzzing. And honestly, I found really, really confusing to understand where the line is. So it's just a matter of names. Anyhow, so for this, I wanted just to say, I agree. There's a lot of join. Maybe none is above the other, just the same thing, and we decided how we wanted to interpret. So the fact that maybe I see search base as broader things, and other people here see like fuzzy is a broader things, maybe it's just a way to say they're probably just the same thing, and we should just use a proper, common naming and common guidelines. I think the about what you're looking for has a huge impact on how we evaluate the tool. So if, for example, if I want to submit a paper on test case generation, then maybe I need to go for a smaller benchmark, but many repetitions to do a statistical test. If I have to target for fuzzing, then I don't care about statistical test. I go for much larger benchmark, one repetition, I found some bugs. I've seen paper, for example, in the top XC this year, which is exactly what I see. I open a search-based paper, smaller benchmark, statistical repetitions. I open a fuzzing paper, we find bugs, that's important, but on the statistical side, it's a bit different, right? Because if the benchmark is too large, we cannot do the repetition. And this I can tell when I try to submit to the two things, really depends on who is going to be the reviewer. So if I know his reviewer is a fuzzer person, I know what I have to target for. It's a search-based person, I have to know what I target for. It's both, then the paper is really on the luck, basically. I don't know who is going to take the strongest in the review process, but that's my personal experience at least.
By the way, everyone, feel free to unmute yourself and talk right after the others. Okay?
I think Mark wanted to raise the hand, or Lionel, or both.
Go, Mark. Go ahead.
Oh, thank you very much, Lionel. Yeah, I tried the raise your hand option on the mid space, but it doesn't seem to do any electronic hand raising. So, yeah, jazz hands. I think there's a consensus here that these are really the same thing. I mean, we could spend the next hour and a half discussing how, minor differences, but actually, so if they are the same, then when you ask what is the difference, I think there is a difference in priority in the order in which things were considered, and that has led to more impact for techniques known as fuzzing than techniques known as SBST. And I think if you look at the origins of the two fields, then fuzzing started off by saying, let's just use random search and see what we can shake out. And SBST started off by saying, hey, we've got these clever algorithms. What's our fitness function going to be? What have we got? Coverage. Okay, let's measure that and try and optimize for it. And it turns out that if you just say, let's find bugs, as Andreas was saying earlier on, just do anything to find bugs and start off with just random. The thing that got people excited about those first fuzzing papers in the early 90s was, hey, here's a bunch of really well-tested C utility functions that everyone's using every day, and yet we find bugs in them. Bugs that you didn't even know were there, bugs that you never even experienced yourself. Now, most people in industry at that point would say, okay, everybody's using these tools, they all work, nobody's experiencing these bugs, so you're just finding a load of bugs that don't matter. But the fuzzing people were smart. They thought, what kind of bugs can you have in systems that lie undiscovered for ages, that aren't really affecting any real users, that don't seem to be causing any real problem, but people should care about? Let's go after security. And that, in my humble opinion, is why all of this fuzzing work latched on to security as the killer app, the vertical that they go after. And they mined it to death. And they went fantastically well, because they just said, we want to find as many bugs as we can, as fast as we can, and it's got to be practical. So we've got to deploy it in industry on big systems, but we're only going to use random search. We're going to make it fast as hell, and we're going to find as many bugs as we can. And that meant that they, if you look at AFL's list of bugs found, it's bug kind of, trophy store. It's phenomenal, right? So I think that that's something the SBST community, the communities are different, but technologically, there's no real difference, right? So the SBST community can learn a lot from that, the power of random search and finding a good vertical. But interestingly, what's happened is the fuzzing community has come around and said, no, we've been doing this random search for about 10 or 15 years, and we found all the bugs we can. What could we do to make our search smarter? Maybe. And then as Lionel was saying, I think it was Lionel, I can't remember, so it's saying maybe we should put these other things around it and have, for smart seed searching, and, let's use evolutionary algorithms. So really now we're in a technical position where the only difference is that in SBST, random is somewhere buried in the heart of it when you get stuck. And the smarter optimization algorithms are right in the core granularity. Whereas with fuzzing, just because that historical happenstance, random is right at the heart, and the smarter stuff is in the outer loop. But really, that's the only technical difference I can see, and it's not one we should, I think, spend too long on. That's what I think.
Well, can I follow up? I actually think that maybe it's more philosophical. And when I think about SBST, I think about a problem, and I think about modeling it as some sort of search problem. And I think about, what are my objectives? And I have lots of different objectives I may use, and they're going to change. And with fuzzing, I think about it being as more of a technique that fits a particular topic, in this case, trying to find security bugs. And so every time I approach an SBST problem, I think about, okay, how am I going to model this? How am I going to represent it? What are going to be my objectives? Are I going to balance my objectives? Am I going to have some sort of Pareto front I'm interested in? And so I think about more of it as a modeling problem and approaching it that way. So maybe under the covers, the techniques are exactly the same, but to me, what differentiates them is sort of the use case and how they're being viewed. And so I'll let others respond to that.
I think we all agree that there are many similarities and that the differences in vocabulary and emphasis comes from the fact that it originated from different communities. I agree with what everybody said, also Annibale. But as a result, it's not just a difference in vocabulary. It has other consequences. The most serious consequence is that the different research communities largely ignore each other. If you look at fuzzing papers, they talk about future work. In their future work descriptions, for example, they talk about things that have already been done, but using a different vocabulary. They do not reference related work. Why? Because that work doesn't use the word fuzz, but rather security or vulnerability testing or search-based testing. And this is, from a scientific standpoint, it's a problem. But of course, it's a problem which has a solution, which is for the communities to work together and to organize common events. I don't know exactly how to do that, but and beyond vocabulary, there is also, and Annibale said that, and also Mark, there is a difference in emphasis. But sometimes, again, this leads to ignoring existing solutions. For example, you have a lot of recent surveys on fuzzing who are asking questions along the lines, maybe we should use the statistical testing in analyzing results. Questions like that, And, in other types of questions whose answer is pretty obvious and has already been worked out, So it's not just a matter of using a different vocabulary and putting a different emphasis on things. It has actually consequences on scientific progress and integrity, unfortunately.
With Lionel here. I was working on a paper with a PhD student of ours at UCL on fuzzing, and they looked into the main shortcomings of fuzzing papers in the past few years, and one of them was lack of statistical tests, for instance, or lack of multiple repetitions, which is something that SBST no SBST reviewer would let it pass, in a paper, that because of all the established ideal in the community. So doing the rebranding, if we looked at each other's literature, we would pick those problems and maybe solve those scientific problems.
Some anecdotes here. In my last reviewing for CCS, which is computer communication security, I always get the fuzzing papers, and I'm happy to review them. So in my last gig of that, I had folks who invented configuration testing. Hi, Myra. So they invented the idea that the program could actually come in various configurations, and one could test these systematically. They even went as far as reinventing pair coverage. Another author invented the idea of rather than calling the program with random input and random system input, how about we call individual functions directly? So they would synthesize sequences of function calls, which they would invoke with random arguments. This was all new. Nobody ever in the community had thought about that. The third paper I had was people reinventing model-based testing. They came up with the idea, if only we had a model of a state machine of things in order to test things, we could actually use the state machine to derive test cases. This is incredible. This is not just rebranding. This is cultural appropriation, what we're seeing. So I'm having fun in these. I'm having fun as a reviewer because I can kill these papers with 2-3 strokes, and I feel like a karate fighter or something. You're dead. That's fun. But what's even more striking is that typically none of my co-reviewers noticed that. So which is what I'm now more or less routinely serving on. I never decline an invitation from the security community because I think that we should serve more on different communities. Maybe, and that's a call for us, for SBST/test generation / community, we should also have more security researchers in our field such that they get an idea of what's going on over here.
Very good. Yeah, Marcel.
Yeah, so I entirely agree also with Andreas, and Mark raised his concern in chat earlier, or his suggested this in chat earlier. We should all come together as a community. And I wouldn't blame the authors for not knowing work that we did in SBST. I think that's something which is emerging from engagement from in between both communities. And without this engagement, we'll just work in silos. We can make a similar point from that Andreas made about fuzzing, not doing statistical tests, and reinventing problems and solutions. For instance, one thing in SBST that always struck me was that we compared. Our fitness function, a typical fitness function in SBST is coverage. You want to maximize coverage, and coverage being a proxy for bug finding. And so SBST work is then published with, we have a fuzzer whose objective function is to increase coverage. Sorry, we don't have a fuzzer, we have a test generation technique whose objective is to increase coverage. And then we measure the coverage of that test suite that is generated. And then claim that our method that now increases, that has more coverage, is better in terms of bug finding than the other technique, the other SBST technique that we had before. And this might not obviously be true. And because of this focus of the security community on bugs, people have actually investigated this. Of course, in software testing, this test suite effectiveness question has been studied a lot too. But recent evidence, particularly for test generation, and particularly for fuzzing, shows that the agreement between an evaluation based on coverage and an evaluation based on bugs might be moderate, might not be strong. So that's interesting because the different perspectives of the communities where bug finding is just not that important. Maximizing fitness function is more important in the SBST community, which is fine too.
So I think we can summarize this initial maybe part of the discussion that these two community, at least for next year SBST, should try to go together. They're related in the problem that they want to solve. And of course, would be important also to include the security dimension. So to move a bit from this topic, general topic, who is fuzzing, what is SBST, we had another probably wanted to talk, which is more difficult probably even. What is the impact of SBST and fuzzing in the last year? So the most complex part is what is impact first, and what you think was the impact that was expected to be achieved and has been achieved actually. So hopefully that's open another door for the conversation. So who wants to start? Maybe you, Lionel, you have an opinion about what is impact or what could be the impact that has been achieved by.
Yes, I'm not 100% sure about the question, but I would say that on the SBST side, the main contribution has been the very deep exploration and evaluation of sophisticated search algorithms for a variety of testing problems. I'm focusing on testing here, it's SBST. And on the fuzzing side, I think the main contribution has been the combination of a variety of techniques ranging from static analysis, symbolic execution, and others, together with some form of search to solve problems related to either white box, gray box, or white box generation. So I think those are the main contribution. And for the latter, for fuzzing, I find that there is a lot of interesting work that somehow smartly combines those different techniques. And I find that interesting as well. Even though in SBST too, we have been trying to combine techniques. I mean, for example, I've been working recently on generating test data based on very complex constraints at the system level, combining exactly this, combining solvers and search. So we also do that on the SBST side, but it has probably been more of an emphasis on the fuzzing side.
Great, thank you. As Mark said, there's a simple impact metric of breadth times width. Is there a way of measuring this maybe on using the impact of those tools in the industry, perhaps? If you fuzz or if you create automatically generated tests for industrial software, perhaps you're going to affect more people. Is there any relation in this sense? Is fuzzing being used more often in the industry? Is SBST is being used as often? How they impact in this case?
I think Annibale wants to join.
Yeah, so I would say definitely here I'm the least experienced with industrial partner compared all the all the panelists. But at least in my experience, industry doesn't really matter if you call this fuzzing or search-based. Probably they know more as fuzzing, and then I'll still do genetic algorithm and test case generation. I would say that definitely fuzzing is a keyword / brand is more known for the security aspect. I think in terms of impact, it's mostly what type of bugs are found. So we use search-based to find normal bugs, null pointer exception, right? But let's say they are important bugs, but not critical. And at the moment we look at I think Marcel said before, at security vulnerability, of course, that's way more dangerous for the company. If you think about a bank and there's a vulnerability that people can steal money, this is a bug, but it's definitely more severe than a random null pointer exception in hidden part of the code that probably is very hard to get from the internet. So in terms of bug, I don't think there's more impact. I think they all find bugs, but definitely on what it matters for the business value. I think if you go to security, there's way more business value because it's more critical. Depends on the type of organization, but then normal bugs. That's at least what I can see. But when I talk to company, because you're definitely using some search-based testing with the partner, business or it's a large financial organization, really doesn't matter to them. I can call it sometimes fuzzer to let everyone understand exactly what we do. But for them, I don't think they really like, I want to use search based, I want to use fuzzing. What they want is some automated tool. They tell the developer there is a bug here and there, and then it just run on the machine over the weekend, and maybe on Monday, there's plenty of bugs that can be double checked by developers.
I mean, to me, I have always, as I just commented, I have always difficulties to talk about the industry or the impact in industry, because I see such a variety of situations across domains. I see many companies, and yeah, I'm not talking about, the like of Facebook and Google's. I'm talking about, the more common companies that you see everywhere, relying on software in one way or another. The level of maturity of test automation is still largely very low. So a lot of the testing is still very much manual, except for the execution part. So I have all these difficulties to answer that. And on the other hand, you read and you hear about very large companies such as Apple, Facebook, Google, who have usually their own software engineering research departments, of course, applying much more sophisticated approaches to testing. So I don't know how to answer that question. Progress and impact is not the same across the board, far from that. It also depends on application domains as well. For example, the automotive industry obviously depends a great deal on software, and increasingly so, but their level of maturity, well, is not comparable to Apple, Facebook, or Google, in terms of software development. And there are many reasons for that. Their needs are also different. Their constraints are also different. But still, that's not the only explanation. So, yes, I'm sure fuzzing is used. It has had an impact in a variety of environments. But there are many environments where people don't use any form of smart test automation whatsoever. Why? That's another discussion. But I'll let the others answer the question.
Right, thank you.
Yeah, I like Mark's answer before the question was actually asked. When he went into Facebook or Meta, how is it called now? He explained Sapiens to them, and they asked, what is this? I mean, is this a fuzzing technique? And so this might be the answer: fuzzing, SBST, impact.
So,
Where's Andreas? Okay, cool. Yeah, I think Mark, you said you're going to have to leave a little bit later, right? A little bit early. Not yet.
Yes, that's right. Yeah, we finish at. Are we finishing in 13 minutes or an hour and 13 minutes?
We're finishing 1 hour and 15 minutes. Yeah.
Yeah.
You still have time. Okay. Great.
not bad. There's still time to talk about.
Okay, good.
I suddenly thought I'd done my calculation of time differences wrong, and I was supposed to be somewhere else.
I mean, this whole time zone thing is a little bit confusing. Anyway, yeah, I think what Lionel said before as well, like the domain in which the testing software is applied makes a lot of difference. As Mark typed in the chat as well, for instance, healthcare applications of computer vision for detecting specific kinds of tumor. Testing these, whether you test it with SBST or fuzzing, it's going to cause a large impact. Very good point. Yeah.
May I? Go on, Lionel. Sorry.
No, go ahead.
Well, I was going to try and introduce a new question for the panel, so you may want to go.
Okay.
First.
Yes. I think anyway, one thing that both communities have in common and that are related to impact is the very difficult question of scalability. When you work with industry and you try to apply any techniques, whether it's fuzzing or SBST, you quickly are confronted to that problem. That most of what is published, most of what is written doesn't scale. And actually that was originally one of the big motivation of using search in software testing and other areas of software engineering. It was to address that issue of scalability. And to some extent it has helped, to a significant extent it has helped. But we always seem to be losing that race. As we make progress, things get larger, faster. So we are running after the problem, without ever solving it. But that's, to me, probably one of the most important obstacles to impact, along with practicality, because there are techniques that are just not practical. If you have to use symbolic execution, but you cannot handle floating points, numbers, like it is the case with symbolic execution, then forget about cyber physical systems. You can just forget. Don't even bother. And then forget about white box fuzzing. So so there are a lot of practical issues as well, due in part to limitations.
To Paolo, I think.
Yeah, so related to this, I think an important aspect is the cost of an individual execution, because in search-based, but also in fuzzing, you have to execute a lot in order to learn, to follow the guidance and get the result that you need. What I really like in search-based techniques, which I'm not sure is available in fuzzing, if you want to make a distinction, is that we have a lot of different meta-heuristic algorithms that we can choose from. And some are more heavyweight, some are lightweight in terms of cost of execution, of computational demands. So if you start with a population-based algorithm, then you know that you have to execute the entire population of individuals before you can assess the fitness and get the best individuals, and you can evolve them. But at the other extreme, you can go greedy. You can use hill climbing, you evolve a single individual, and then you get to something maybe locally optimal, but still useful in a much more fast way. So that's an interesting aspect that I see in search-based techniques. I'm not sure if in fuzzing they invented something similar, or if they have this kind of configurability of the cost of the execution, because that's a big obstacle to the applicability of these techniques.
So there's been a lot of research in speeding up fitness functions, speeding up the coverage feedback essentially, and using machines like CPU features for this, hardware features for this. So there's some research in reducing the cost as much as possible.
Okay, maybe I can add something. So Paolo, what you mentioned, right? They have different search algorithm. So I've read, obviously, not as many papers Marcel had done on fuzzing, so correct me if I'm wrong. But from my understanding, many papers on fuzzing, they do use evolutionary algorithm, but often they don't call it like that. So for example, there is the initial seed, which is what we call the initial sample, initial population, and then they don't do crossover, they just mutate, for example, some seed, or they randomly sample new seeds. But this is in evolutionary computation, it's like the mu lambda evolutionary algorithm without crossover. At least when I read some of these papers, it's exactly the same thing. So you have some sampling and you mutate in sampling to search around in the region, but just not called evolutionary algorithm. It's called mutation-based, whatever, or seed-based, etc. But of course, Marcel, you are the expert here, so if I'm saying something wrong, feel free to stop me. I know some people do cross the line between fuzzing a search-based where the crossover is there or not. So I've seen some people like, we don't use crossover, so there's not a search algorithm, we just use mutation. This is fuzzing, but there's a category evolution algorithm also without crossover, and hill climbing is an example. So I said this is also one thing I found a little bit fuzzy on how we define when an algorithm is evolutionary algorithm, when an algorithm is actually a fuzzing algorithm. So it's fuzzing in the fuzzing, yes.
Would you say it's a fuzz, kind of like a fuzz topic? Fuzzy topic? Right.
Should I respond to that?
Yeah.
Okay, so people in fuzzing don't think of the typical gray box fuzzing algorithm as an evolutionary algorithm. They think of it as more like a novelty search. You simply, the algorithm is very simple. You keep on generating inputs. You start with an initial corpus. You modify the seeds in that initial corpus that you call initial population. And anything that improves the fitness, any input that increases coverage will be added to the corpus. Every other inputs will be thrown away. So there's no population that is being evolved like in evolutionary algorithms. It's just adding new inputs that increase coverage to the seed corpus with the intention of fuzzing that input and increasing coverage further.
If I may say, then in that case, I would call this an archive-based evolutionary algorithm. There is no population, it's the simple hill climber with an archive. So you run new, and when it's new, you add it to the final archive. There's even actually a later version called double archive. Yeah, but there are variants of, so the thing is, at least I'm not an expert in evolutionary computation, but in the optimization based on evolution, there's many sub-variants of evolutionary algorithm. It's true that in SBST, maybe we stick too much to classical genetic algorithm. There are so many variants with population, with multiple population, with archive, with multiple archive, etc. So in that case, for what I understand from your explanation, I would call it that an archive-based hill climber.
All right. I think Mark wanted to introduce a question before, Mark.
Hi, yeah, I did. Can I introduce you to my friend I brought along here, who's been in the room? We've been in the room. This is my friend, the elephant, who's called Oracle. And she's been in the room for an hour now, and we haven't mentioned her once. So we did agree that these two technologies are largely the same. So it would be good, therefore, particularly if we're thinking about how can we build a community shared, get them together and so on. It would be really great if we could actually work out what is a shared problem for both communities, because then we could have workshops on how we can tackle that, and then all the differences would fall away. And it seems to me that both these technologies, the ways they've developed, have got this real problem with the Oracle problem, because we essentially what fuzzing did, sorry, Andreas, I'll yield to you in a second. I can see you're very keen to. I want to finish my framing of the question. So, the reason fuzzing was so successful is because it went after the implicit Oracle really early on. We went after, in SBST community, we went after things like coverage, and we had this a huge panoply, as Paolo was saying, of possible things we could go after because we got fitness, whereas they just had this simple hammer, right? Just go after random search. So whenever I've seen any testing technology be successful in industry, it's almost always been because you just go after the implicit Oracle. Things shouldn't crash, things shouldn't go out of memory, these kind of things. When it always gets harder is when we try to imbue the technique with some kind of Oracle intelligence. And I feel like the reason I'd like to spend some time on this is, firstly, I'd love to ask the audience, like on Who Wants to Be a Millionaire? I tried phoning a friend. If I was a fuzzer, I'm sure I'd do 50-50, but ask the audience, like what ideas could we have on how to solve or tackle the Oracle problem? Because this would be interesting to fuzzers and SBST, I think. Anyway, sorry, Andreas, I think you're keen to talk.
Yeah, I also saw the elephant in the room, so the Oracle problem, of course. And I'm happy to report that in the fuzzing community, there is no Oracle problem. It simply doesn't exist. If the Oracle problem, these very words exist in the security community, and this is about the Oracle problem in Ethereum contracts. By the way, today, if I Google the Oracle problem, I end up with Ethereum contracts, certainly not with anything related to test generation. Maybe it is related to test generation, but the Oracle problem is also a word that now has been culturally appropriated, has been taken over by some other community apparently. Now, why is there no Oracle problem in the fuzzing community? Because it's all about exploitable bugs and a crash. Some undefined behavior is something that can actually be turned into an exploit. That's the first. That's what you start with. A hang. If the program hangs, this can be turned into a denial of service attack. We have crashes. We have hangs. We have depletion of resources. Depletion of resources also is an attack. There you go. This is it. All these are generic, implicit, and there's no need to specify anything. Having said that, the really, really big security issues that have made it into the front page of our newspapers are not related to crashes at all. Think about Heartbleed, for instance, when a TLS server happily sends out all sorts of memory contents, including passwords and whatnot. Think about recently, what was that? A Log4Shell, for instance, where anyone using some dollar curly brace, whatever, JNDI thingy, can execute a shell on a foreign server just because we can. Boom. These are all things that in principle could be found by fuzzing / test generation / test automation whatsoever, but they're not. And they're not because they go under the radar and because we don't have oracles to check for these. And the fuzzing community doesn't see this because for them, these are things that are, well, would require some kind of specification, and the word specification is actually hated over there because you have to understand you're talking about other people's programs. The last thing you want to do is to write a specification for someone else's program, so they're not really willing to do that. But if we can come up with better notions for oracles, possibly generic oracles for security issues, thou shalt not leak this data, thou shalt not gain control over that, and if we had means to also validate these during testing and actually guide our approaches towards the ability to control things, towards the risk of leaking things, yeah, then we could make quite a splash.
Paolo.
So I agree that if we go for some more subtle properties, the Oracle becomes more difficult. So if even in security, if you want to prevent SQL injection, common injection, or escalation of privileges, these kind of things, then the Oracle is not definitely, the application should not crash or something like that. It's you have to encode it. But I see a difference with respect to functional testing, because in functional testing somehow the Oracle is very application domain specific or very application specific. In security, you are a little bit luckier because all the ones that I mentioned are security properties that should hold across applications. So of course, instantiating them for a specific application is not trivial, but at least you have like a high level description of what is a security property that should hold, and the problem becomes more a translation problem, which is not trivial, of course, but that's the kind of problem you have to face. In functional testing, even expressing the specs, what is a desirable property is difficult and probably is not reusable across applications. So in this respect, doing functional testing seems harder to me.
All right. Well, I think I have echo on my side. I'll try to. Do you hear any echo? No, okay, then it's my side. Okay, that's easy. No, I wanted to add, this is in theory, right? So fuzzing is about security, and search-based is about other type of testing. But I have to be honest, lately I'm getting very confused on what I see, because now we have also paper that, for example, do adversarial example for machine learning. It's called fuzzing. But we also have like the same thing, search-based technique applied into security, and then we can call it search-based, just ignore completely what the fuzzing community has done so far. So I think it's good that we are discussing this, and we should definitely probably open up in between the sub-community. We are at the moment, right, that actually we start crossing the line with just different terms that we don't really know. I'm talking for myself, for example, what is done on the other subfield. There was, for example, lately, as an example, in cyber physical system, testing for self-driving cars, and we have like half of the paper called as search-based testing and half of the paper called as fuzzing testing for finding not vulnerability but exactly the same type of things. So car crashing, accident, etc. And obviously, at least my anecdotal evidence now, if I put fuzzer in the title, I have to go for certain standards in the evaluation. So many runs, bugs, we don't care about coverage, etc. If I go for search-based, maybe I'm not super sure about how many crashes I have, but I have to provide statistical analysis, lower random things, etc. So I think the problem, at least I'm facing as orders at the moment, it really depends which keyword I put in the title, what type of, okay, obviously we do research for research, not for getting accepted or for making the reviewer happy, but there's some kind of relations in there. And I think we are definitely the problem where if we target the same problem, we don't know exactly at this point which of the two stands. We have to my view, two different standards for evaluating things. And since now we apply the same technique, not only in our confined sub-area of security and non-security, I think I've seen at least a bit of a problem. I have a problem in classifying papers when it's not about security or functional testing, for example. And also how do we do the evaluation? So that's probably something we should work together to establish common guidelines, empirical guidelines or something on those lines. I don't know what is the thought of the other panelists about that. If you also face the similar issues as well, both as authors, also as reviewer.
So one of the panelists here, Lionel, is one of the authors of one of the most influential benchmarking papers for randomized algorithms. So I think it already sets the scene for what we at least expect in the minimal sense.
Yes. The Oracle issue, as I wrote in the chat, to me is orthogonal, but of course highly important. Any test automation technique needs a way to obviously detect failures automatically. And of course, if you only rely on crashes and such runtime problems, you limit yourself in terms of your capability to detect problems. And in my experience, there are a lot of critical problems in practice that do not lead to crashes, even in security, where the system doesn't crash but leaks data, for example. So then you can just ignore that. But I guess anybody interested in test automation has to be interested in the automation of test oracles. I mean, it's an unavoidable problem. Hence, for example, the rapid development of the array of research referred to as metamorphic testing, whose objective is to help minimize the effort associated with automated oracles, because that effort should not be proportional to the number of test cases you execute. Well, yeah, I agree. But I think it's a little bit different than the main focus of this panel, though.
So I think you wanna.
Yeah, so I think one of the most exciting recent developments in the Oracle problem, I don't know whether it belongs to the fuzzing community or the SBST community or the general automated testing community, is equivalence modulo inputs, EMI testing, where you have, and they find a lot of bugs recently, and particularly under Chen Dong's group. When the key idea is essentially you take something and you have an expectation, then you make a change to that something, and then you expect a certain change at the output. Okay, let me be more concrete. You're testing a compiler. A compiler takes as inputs a source code, right? A source code that is being compiled. What you do is you don't need to know anything about that compiler, but you know how you can change that source code in a way that it doesn't change the meaning of that source code. Maybe you inject some unreachable statements. So you change that source code and see what the compiler does for this. And then you compare these two executions, the original execution and the expectation for that execution that you have. And if there's any difference, then you report that as a bug. And this is a semantic oracle because even though you don't need to know what the compiler does and how it compiles anything, it shouldn't change. You can do the same for databases. You can do the same for SAT solvers. And I think there's a lot more to explore in this direction.
I also think there was a keyword used by Lionel before, test cases. Perhaps in SBST the oracle is more visible in a test case with all the assertions, whereas in fuzzing your oracle is the crashing, right? And this leads to a small difference that I observed, which is, at least that's my observation, which is in SBST we are concerned in generating good test cases, and in fuzzing it's more like system testing, isn't it?
So can I follow up on that? I agree with this. I think in SBST the focus has really been on generating the tests and making them more human readable and making them and tying them more to the problem. Whereas fuzzing, I think the tests that are generated, it's less relevant if they're something that I can comprehend. And so I think that people have also focused on really minimizing the tests and getting good coverage in the SBST community, which helps you at least have a potential for manual oracle development. So I think that there's been probably more focus on the functional oracle rather than just crashing in the SBST community. But and I agree with the metamorphic part. I think we should be thinking about how we could do metamorphic testing both in fuzzing and SBST, because it's a really interesting question, and I think that's the future of a lot of oracles that we don't have, because we're not going to have functional outputs as we move more into ML and other environments.
Great, thank you. Mark, is your question about Oracle answered? Do you have something else to add?
But I don't propose you need to necessarily spend more time on it if there are other things we should be talking about. Oracle's happy you talked about her anyway. Let's see, she's smiling in it.
Okay, cool. I think there's another point that I think we could talk about, and which is the domain in which those two techniques are usually applied. For instance, is there any difference between applying SBST or fuzzing and the popularity between those two techniques in, let's say, mobile applications? What is used currently for testing mobile applications, or, testing ML, as someone mentioned, right?
I will also add, as Eric mentioned in the chat, superficial system and maybe enabled systems, make it broad and connect to the keynote today. And I think Paolo already exhaustively answered, but I think many other people want to join on this, since we are talking about fuzzing SBST in a general sense.
Okay, no comments on this? Guess it's not interesting. Okay. All right, so I guess we can perhaps talk a little bit about some shortcomings of the techniques. As someone mentioned, there is the scalability problem, which everyone's concerned, and there is research currently being done on reducing the cost and making it more scalable. But do you have any insights on the current limitations of the techniques, and where should we focus or test automation research? Let's not say fuzzing SBST anymore. what are the main limitations for those techniques? What we should be focusing right now?
I mean, to me, my experience when working on real problems in real context is that using one type of technique, meta-heuristic search of some kind, any kind of program analysis, usually doesn't cut it. Usually, the solution requires a smart combination of techniques. And actually, that's what fuzzing is doing to some extent already. But I was never able to solve a real problem in a real context by using only search or by using only a given technique, whatever it is. I always had to somehow think very carefully about how to smartly combine them. So search-based SBST should not restrict itself to search techniques and should interface with other communities if we, like actually the fuzzing community has been successfully doing so. If we want to solve real problems in a practical and scalable way, and it's not easy, of course, but I think it's indispensable.
So Paolo, I think you were raising your hand.
So a follow-up to what Lionel just said is to my experience, the importance of surrogate models. So that's something that is not so much used and explored in the research, but whenever I face a complex problem, currently I'm working a lot on deep learning systems like self-driving cars or drones, and cost of execution is a big issue, and if you can replace some of these executions with a surrogate model that can anticipate, that can predict what's going to be returned by the fitness, then that's going to help a lot. And I mean, Lionel is one who investigated this. There's great papers by Lionel on this. We are also doing it, and that's probably something useful across both communities.
I have 3 problems that come to my mind immediately, where things that we should work on. One problem that is, and I think I resonate with Lionel and Paolo here, one thing that is commonly under-researched or underestimated is the effort for setting up test automation. Also, if you think about, I am just going to use a fuzzer and I'm going to throw this fuzzer to the input of the system, where is that input? How can I actually start the execution of the system? How can I feed this input into the right place? This is in practical systems, which are not just whatever some Unix utilities with standard in and standard out, where you can make this whole thing a part of a pipeline. This is a big, big problem. Suppose I have something simple, an Android app. And this Android app communicates with the server, and I want to fuzz this server interaction. How on earth do I do this? Well, I can have a PhD work on that, maybe for a month or maybe for 2. Then he or she may come up with a solution. But this is difficult. This is hard. Simply figuring out all the many, many ways a system can interact with its environment beyond just standard input. The second thing, is performance. I mean, we are routinely talking about settings in which we graciously assume that we can execute a program 100,000 or 1,000,000 times. Why not? I mean, I recently had this discussion with a PL person, and we said, I want to use a grammar for producing valid inputs. He said, why do you do that? Why don't you just generate random inputs and call the compiler every time until you finally get something that is actually syntactically valid? Interestingly, that works if you send a single semicolon to the GNU-C compiler. That's actually a valid C program, so you're done. But the thing is, you cannot simply assume that this is actually feasible. If you're talking about testing cyber physical systems, you may end up with settings in which 1 run per minute may be the right thing to think about. Okay, so this is so this means that we actually need means to extract models from these systems and test the models rather than the actual real thing. Lionel has had an ERC proposal on these very topics. But these are things that any kind of test generation would greatly profit from. And while we're talking about extracting models and testing these models, one thing that is true for all sorts of test generation, academic test generation research, as I've seen it, is in practice, people have a good idea on where the bugs are. And they have a good idea on what should be tested. And they have a good idea on where, on the properties of an input that actually might help in finding bugs. Yet all of our settings assume there's no human in the loop, which is fine for automatic evaluation because, yeah, let's just send this off and let's hope that it's going to find some bugs. But in practice, you always have developers who have an idea of what should be tested and what should be tested most, or where the past bugs have been. And this is not just data that one can go and extract automatically from some bug repository. Yes, you can do that too. But we seriously should think more about finding ways to integrate humans and to give humans control over what is being tested and how it is being tested. And these three things, increasing performance, not requiring millions of test executions, easing setting up things, and giving users control over what is to be tested. These are things which may be less attractive from a research point of view. It's like, say, build systems, something that, or build systems or configuration systems, packaging on Linux, whatsoever. These are things that do not necessarily attract much attention from the academic side, yet there's so many people suffering from them. And putting humans in the loop, yes, this is far more effort than doing things automatically. But these are things that can make our tools far more powerful and make them far more integrated into the daily routine of our testers.
I guess this is an interesting topic, humans in the loop testing. So maybe other people wanna elaborate a bit on their point of view on that topic, on this topic.
I'd like to just bring up one other issue that I think is that we haven't talked about that's really important with both of these topics, is this idea of flakiness, because we're using these automated techniques, and I've experienced this both in the SBST community, but also when using fuzzers, and we're executing things a single time, we're trying to cover something, and so I know that a lot of the SBST techniques at the end, once we've generated the tests, we can now go back and confirm that they really do pass or fail. And so maybe there's a little more built-in ability to detect flakiness, whereas fuzzing, my impression is that we get what we get. So I'll leave that open and see if people want to answer that.
Well, flakiness is related to the oracle problem we talked about before. I mean, partly. Obviously, whether your tests are flaky also depends on how, how, I don't know how to say that, how accurate, I'm not sure that's the right word, your oracles are. So the two are related, but of course that's not the only factor of flakiness.
I'm pretty sure if you ask anybody in any practical testing scenario, what's your biggest problem, bugbear, they'll say test flakiness. So I think Myra's raised an important point there.
Yeah, I think one aspect of flakiness is related to the guidance that you want to give to the search process, because sometimes to get guidance, you have to somehow mitigate flakiness. If you have like a complex environment where different executions are always slightly different, because I mean, the environment itself is non-deterministic. Then if you want to get usable feedback for the process, for the generation process, then you have to do a single run multiple times, and then you have to average, or you have to compute the worst case scenario in multiple executions, which adds to the cost of execution problem. So really it makes it explode.
Regarding the human in the loop, I find that this is a very large source of uncertainty and complexity in what we do. And the reason is that we cannot make any assumptions about the human in the loop in our profession. You know, I don't know, in other professions, if you are civil engineers, where you can make some assumptions about how a civil engineer works and what he knows, you know. But a software developer, I mean, you know, given the variety of software developers I've seen in various domains, you cannot make any assumption. So then if you cannot make any assumption about what they know, what they can do, what they cannot do, it's very hard to devise a solution that you can claim is generally applicable. I mean, usually that doesn't exist.
Marcel?
Yeah, so I have two aspects on human in the loop. The first is when you talk to people in the industry about fuzzing versus static analysis tools, the first problem they point out is exactly which Andreas said earlier. You have to set up the fuzzer. You have to somehow glue the fuzzer to your target. And so this process of gluing your fuzzer to the target is very elaborate, and people that don't know fuzzing require some guidance. So there's some research in fuzzing about generating this glue between the fuzzer and the target. But still, I mean, if we could help with these manual processes. So static analysis tool, just for comparison, you just point the static analysis tool to your program. It doesn't even need to compile, and it tells you which bugs there are. So how can we help the human in kind of setting up, making it easier, onboarding your project in a very simple way? So for instance, VS Code, which is an IDE now, also integrates some initial fuzzing kind of annotations you can do. And the second aspect that I would like to talk about is when you look at Google Zero. So at Google, what they scale a team of 5 people to 25,000 machines using fuzzing. They can fuzz 500 open source projects, and there'll be more on these many machines. So fuzzing allows you to scale a small set of people to a large number of machines, and it finds bugs, and it continues to find bugs forever. Right? But Google also has another team, which is called Google Zero, where they actually employ the lead hackers to find bugs in your programs. So they also use fuzzing, but in not as a process that starts from setting up and then continue let it run forever, but that uses fuzzing more like an integration into their search for these bugs. So they look for, as Andreas said, they have an intuition. This is where maybe we can find a bug. So then the objective is to generate inputs that would then expose this bug. And so they do this in a very iterative way and followed by intuition. So maybe another way of looking at fuzzing and human in the loop fuzzing is how can we integrate, how can we kind of scale that elite hacker team better by just providing them better tools, bug finding tools, and fuzzing could be one component in this.
Annibale? On the spot.
I think Annibale just left. Oh no, he's back again. Okay, I'm going to start anyway. Okay, there is research that is simple, and there is research that is hard. Research with humans is far more complex and far harder than anything I can just kick off automatically, maybe on 500 machines at a time, If I come back with bugs, that's all fine too. Having said that, though, the amount of automation we're having right now also encourages benchmark-driven research. So as long as our efforts are being evaluated, not even by proxy measures such as coverage, but actually by statistically very shaky measures such as the number of bugs found. What does it mean? One technique found one bug, the other one technique found 0 bugs. What is the statistical meaning of this, if at all? Okay. Yet I see this plenty of times in security papers. Our technique found 3 bugs, the other one found 2 bugs. Therefore, our technique is better. Having said that, the 2 bugs that were found by the old technique actually were found ages ago and have long been fixed. This is not a good measure. If there was one thing I would wish for, and which can also be subject of research, is actually far more independent evaluation of tools. It's far too easy when you are doing things automatically, in particular, to twist your research such that it fits a given target. You want to find a particular bug. You already know that this bug exists and you want to find it. Yeah, sure, I can turn a couple of screws in my hyperparameters. I can adapt my algorithm such that it searches in the right places and for the right amount of time. I've even had stories of groups employing hackers to find bugs first, and then later the tool was tuned to rediscover these very bugs that were already known. And that's something I find, and combine that with the fact that, in particular in the security community, sharing of tools and data is largely not done. So you cannot simply download the whatever fuzzer from this and that paper and try it out on your own benchmarks. No, that's not possible in most cases. Not even as a reviewer you can. So typically papers contain this wonderful series. We will release the tool sometime after it has been accepted. Where sometime obviously is like in temporal logic, always eventually release or something, but no idea of any time frame. And if there's some kind of research that I would see, it's not so much about, we came up with this novel tuning of using whatever neural nets to tune the AFL choice of such and such in order to be even better than before, because none of this is actually motivated by any observation or so, just comes out of the blue. What I would like to see is much more independent evaluation of tools, and also research standards that allow us to do that. Because if I can tune my approach arbitrarily towards a particular benchmark, well, what does it mean if I then produce a tool that fits that benchmark? Actually, these papers are not even harmless; they're actually harmful, because others will be asked to compare against this tool, which is going to be very difficult if neither the tool nor the benchmark nor anything else is actually available. And that's something where I see, and we see plenty of papers like this, hundreds of papers where people do some arbitrary twist, and yet they are better than whatever was before. Oh yeah, how cool is that? And the tool's not available and the data is not there. This is not really helpful for research and test generation in the wider sense, whether you call it fuzzing or search-based test generation. I see this more on the fuzzing side of things. So, so you can all feel safe and non-threatened. But that if there was one wish where I would like to see more research, then it would be in actually trying out things and comparing things and finding out where the strengths of individual tools are and where the weaknesses are, and not as told by their creators, but as told by impartial evaluators.
Annibale?
Well, actually, I had something to say first, but given the hint of what Andreas said, actually, I would like to continue on that a little bit. I think, Marcel, you published a paper recently, right? It's 10 out of 42 files that were actually available publicly, which is actually in the line of what Andreas said. I think about the benchmarking, but there is a common problem I see actually between fuzzing and test case generation, the benchmarking, that we use a benchmark of known bugs, because that makes the evaluation of the paper easier. Like we have 10 bugs, we know them, how many of those we find. But rarely I've seen actually paper that try to see, do we find new bugs as well, other than the one that actually are already part of the benchmarking. But that's obviously takes much more time to analyze each individual test, each individual crash, which make much easier not to run a CI/CD pipeline, run any tool, and if you find one extra bugs in the set of known bugs, that makes the publication much easier. I would say this is an anti-pattern I've seen in both communities, not only fuzzing and not only test case generation. So actually, I wanted to say something on the previous part about putting developers into the loop. I think that it's important to add the sets in the beginning of the process, right? Because developers knowledge about exactly maybe where is the bug, what is the most difficult part of the code, the most complex part of the code. But I think we also need it afterwards, right? So we use fuzzing or test case generation, we find an exceptions. That's a bug, but obviously the bug needs to be fixed. So even how we provide the data and how we can explain why the crash happened, so the root cause analysis, is something that also haven't seen that much as well. Right? I found a bug, we are happy, but is the input that triggers the bug that easy to understand for developer? At the end, it's something this I would say widely unexplored as well. I think I've remembered a few papers 10 years ago, I think from less 5-6 years ago from Phil McMean about, for example, English-like readable inputs for string related programs. But that one is well, right, because that makes it more difficult as well. So we find crashes, we are happy paper published. But are those crashes easy to understand? Are the test cases easy to understand with the test input? If you look at the fuzzing part, that one I think we should also work a little bit more.
Should we rebrand the research terms?
Yes, I think someone in the chat mentioned test automation, but there's a devil advocate. I think in industry, testing automation is called for test execution. There's an entire developer-oriented is about how to run the test in automated fashion, multi-parallel fancy machines. So I'm not even sure that the test automation is the right keyword here, if you don't want to confuse the practitioners.
Yeah, but there is no term that will not confuse some constituency of some kind. So, at least you can logically justify that phrase and explain that automation covers not only execution, but also generation, oracles, and so on.
Shall we call it automation 2.0 or deep automation?
You are good at new keywords. Yeah.
All right, great. Well, those are certainly many problems that we can advance on. I think we mentioned scalability, human in the loop, flakiness, and many others. And I just want to point out something very interesting. When Myra said flakiness, everybody nodded, said, yeah, that's a good point. Mark also went far and said this is one of the most troublesome problems in testing, but I don't think we mentioned any fuzzing or SBST paper that tries to acknowledge this problem and tries to solve this problem. What do you think is being done right now in search, in automation 2.0 to solve this problem? How should we solve this problem? Because this is clearly a hard one and a very impactful one, right? Do you have any insights on what to do forward?
at least in the search, at least in the SBST community, I mean, I think this is similar in some ways to, you think about like overfitting, or, you know, you have tests that maybe are too weak. And so with a lot of times after we've searched, we rerun our test cases to see if we get similar results. I think that's the way the SBST community has tried to that. Perhaps crashes are less flaky, and I don't know, maybe that's why fuzzing hasn't addressed it as much, but I've seen some fuzzing tests recently that I was surprised were flaky. So I think it's out there, and I don't have perfect solutions, but I would be curious to hear if other people have them. So.
I don't know if this is helpful, but one thing that I found in our company, and I think it's true in others as well, is there's an extra step when you deploy these tools that we don't tend to look at in the research community. And I think it's a step where you run all your test automation and you get some results from it. But then in between that and the developer, there's a separate piece of logic that decides what signal from all of this. Think of it as science. You know, we do all this scientific experiments, automated or with human in the loop or whatever, we get some results. We don't just dump all that on the developer. There's a separate piece that says, let's decide what of this signal we're going to pass on to the developer. It might decide, for example, yes, this test failed, but it's flaky. It failed, but it's not an important bug. You know, so all this stuff, this piece, in many of the companies I've seen, that there's a lot of effort goes into working out what to put in that piece, and yet it's not really something we research about. And I think if we could think, perhaps tackle that through the lens of at least asking, well, what would you do if you had all these results, but then you just have to decide what signal to pass on in terms of at least not bugging people about flakiness, then that would actually mean that a lot of the technologies that are developed in the academic community would instantly move a step closer to being immediately deployable.
I think this is a good point, Mark. Those signals, and it's totally doable, right? Because we have many executions of fuzzing for hours, and you have many executions of SBST. You have a lot of information to pass out. You just have to find those signals in there, right?
I mean, people have said that the research community tends to overfit on things like benchmarks and so on, and that's true. But maybe that's just a behavior that is natural given all the kind of wider pressures to publish and so on. So maybe there's a way to turn that to an advantage by formulating some of these. I suppose that's down on us in industry to do this, but anyway, formulating some of this middle piece that seems to be missing in most research papers. Just say we find this many bugs and that's good, we're done. We find more bugs than them, so we're better. But actually, this whole thing about deciding what signal you would pass on to developers to make it most actionable and so on is a kind of missing piece in the research picture. I guess to make it less missing, we'd have to actually try and turn it into a more crisp research question. So I'll shut up at this point and let others talk.
Thank you for your answer. I guess we have still 20 minutes, and I would like to use those 20 minutes maybe to talk about the path forward now. I think we have established that SBST and fuzzing are two communities with very similar problems, very similar research questions, many small differences. But what do you think would be the path forward to, bring the communities together, make one more aware of the other, perhaps stop rebranding things and citing papers from the other community? Is there anything we can do to solve this issue, this gap between the communities?
Yeah, one thing that we wanted to touch in this part is, for example, education could be one thing that could help moving forward from new, PhD student, new master courses that could go on the long line. We'll have search-based, fuzzing, and showing, for example, the relation to them.
Well, I think Marcel already wrote something that I definitely agree with. Joint workshop and touch tool, seminars, etc. The other thing is maybe having hybrid program committee, right? Because we already have some dedicated workshop. SBST is an instance, but it's also the fuzzing workshop, I think last week or 2 weeks ago, I don't remember. And probably we built the subcommittee, right? Invited the same people and the same speakers, the same talk. This is the other things. Maybe the other thing we can look at also is to writing common shared guidelines for evaluation. There is something done lately on empirical evaluation. I think MC also was leading in that to build guidelines on how to evaluate also empirical study. Maybe there's also something we can do, knowing that no, we have different ways to look at evaluation and find common truths between the two sub-community. There might be a way to do that. Yeah, and probably using a common naming or keywords or whatever to be sure that we don't target sub-community as well. These are possibly, at least my view on this. But I would definitely rather go on the common shared guidelines on how to evaluate randomized algorithm, whatever that is, fuzzing or test case generation. Of course, Lionel, your paper on statistical analysis will be the top of the item list to look at, but that would be something to look at.
So should SBST next year be a combined SBST fuzzing? I was calling it SBuzz. I don't know if that works, SBuzz, but I feel like should we make an explicit effort to try to put the communities together, and would that work? Would people, or are people just going to stay in their own silos? I'm not sure. And we have different approaches, and so I'm worried that bringing people together is not going to be as easy as possible.
Well, I think that could work. This year, for instance. Oh, sorry. Go ahead, Andreas. Daniel.
No, Andreas has a very good suggestion to even add to the current confusion.
I'm sorry here, but I agree with Marcel and what has been said before. I mean, there's some commonalities here. We're all interested in generating tests. We're all interested in finding bugs. This is true for all. This is what unites us. Whether we consider ourselves security researchers or software engineering researchers or practitioners, we want to create good, reliable, bug-free software here. And actually crossing boundaries here, getting inspiration from various communities in various domains, finding out where the pitfalls are and where the successes are. This is great for us. This is exactly what we as researchers should be doing. And if the word software testing, maybe even search-based, if this keeps particular members of our research community out, maybe we should try to be as inclusive as possible.
Yeah, our joint goal is to find bugs, and we can develop and explore these techniques. And I think what we can raise the bar of is to make our science more reproducible, publish our tools, increase the soundness of our evaluation, and then be inclusive, as Andreas mentioned, and then actually facilitate, instead of arguing that the other community is stealing from the first community, and essentially facilitate the integration of both communities by organizing meetings, organizing joint workshops, organizing Dutch tools. I think all of us have the same goal, and so I think we should just continue this conversation, essentially.
I agree. We should join forces. By the way, Mark has to leave now. Mark, thanks for joining us. He's gonna leave a little bit earlier. Thanks for all the comments, and yeah, thank you. And I think, as Marcel said, joining forces, and also Myra mentioned about like maybe including fuzzing in the SBST next year. Actually, this year we explicitly added search-based fuzzing in the call for papers. Although we didn't receive any fuzzing paper, let it be known that SBST also accepts fuzzing papers with search. Yeah, right. And I guess maybe next year we can think about probably including fuzzing in the tool competition as well, attracting more submissions that could, join both.
What about in the SBST tool competition, if we advertise it more for, we can have fuzzing versus SBST, and that would start a interesting competition.
Yeah, definitely. Imagine putting both in a boxing ring and see who wins. That could work. So I guess we can use. Okay, anybody?
Okay, maybe it's the very end. I'm sorry if I'm breaking this very conclusion discussion, the path forward. I posted something in the chat. I really want to know what's the panelist view of it. So we all agree, right? Fuzzing, search-based. We have a program. We want to find an input that reveals some counter or misbehavior or crashes, bugs, whatever. Now, if my input is an image and my test, the program under test is a machine learning, how should we call that? Search-based testing, fuzzing, or select sample generation?
Well, I think in deep learning testing, you see all of these, all the combinations. You see, well, if you look at the names of tools, there's DL fuzz that is very popular. It's a fuzzer, right? But it's not very different from other tools that generate using different search-based techniques. Input images for GAN-based image generators or search-based generators. So I think you find the same problems and the same overlaps as we have discussed today.
Thank you. Well, let me share with you then. I think Sebastiano was doing a great job during the entire discussion here, taking notes of the main discussion points and summarizing what basically.
So we need inputs from you if you are in the right direction, what to take for next year, what output will be at this meeting.
Exactly.
Maybe you go over a bit.
Would you like to?
What were the easiest? There were different. No, it's okay. You can go, Giovanni. It's not a problem.
Yeah. Well, would you like to share the
Yes.
slide?
Yeah.
Lionel, yes, please.
I think there is a tension between two aspects. One is that it's natural for researchers to somehow regroup according to the type of technology they're interested in, whether it's meta-heuristic search or whatever else. And you find that in many areas of software engineering. So some people are interested in symbolic execution and so on. The problem is that this is not fully, this is not very effective in terms of problem solving. And in the end, we want to solve problems because it's an engineering discipline. And the goal is to solve problems and more, and even furthermore, we need to solve problems in a large variety of contexts that require different solutions. Context being defined by the domain, the type of system being developed, the technology underlying the system, and so on. So we have that contradiction. As researchers, we focus on technologies we're interested in, we regroup according to that, and because we like to discuss with our peers on whatever aspect of search, meta-heuristic search or symbolic execution or whatever else. And on the other hand, we need to solve problems that require multidisciplinary solutions. And somehow we have to resolve that I'm not too sure how, but we have to resolve that if we want to have more impact. And both are justified. I mean, of course, it's justified to discuss with your peers about particular types of techniques you are commonly interested in. There's not, there's nothing wrong with that. But we have that tension between those two objectives that we need to resolve. How is not easy, and I don't. It could be a very long discussion, but I don't want to continue on this. I'll let other people speak.
Okay, I will try to share the screen. I think I am having a problem with the access. Let me see now. So probably, John, you have to go because I think I want to have use efficiently this time left, and we want to go over the few points that I try to summarize, but maybe. Yeah. So it seems to be that at least from the beginning of the conversation, it was very difficult to all of us to position in what was fuzzing, what was SBST, because they target very similar problems and they have very similar techniques. So one thing we could already do moving forward is SBST to be more inclusive, starting with the naming. Maybe a provocative one would be search-based fuzzing, but maybe could be something a bit better, more tuning. But this is not really come so easy. We have to agree on the reviewing criteria because they have been evaluated in different ways. And Annibale mentioned a few times, but not all him. And of course, means also change the way the tour competition is made so far. We try to have a competition very inclusive. There is no differentiation really between fuzzing and SBST, but they are targeting the same problem. We try to think about what are the actual criteria. So I actually use the terms from Lionel. So we probably SBST and fuzzing community should work together. And what means that? It means to organizing common events, seminars, hybrid PC members. It could be one way to make it happen, making people applying to our calls. For sure, this means also to have criteria that are related maybe also to fuzzing. For example, the focus is security, has been talked a few times. Scalability is one important aspect to consider. When we go for complex system, surrogate models is something that maybe can achieve the goal of addressing assessing the reliability of those systems. But even more challenging probably is very not yet clear how to do it is humans in the loop. That was been mentioned a few times by Andreas. And of course, scaling execution cost is really something that need to be addressed in a different way, in different forms. Yeah, fuzzy, sorry. And last but not least, probably even the Oracle probably could benefit to combining and putting together fuzzy fuzzing and SBST technique together, where one complementary problem that has been mentioned by also Myra and Lionel is flakiness, which is a complementary problem. There were probably the three main dimensions that we have identified. I don't know if we have missed anything on the way, but if there is any topic that you think should be included for moving forward the community, we are here. No.
Thank you very much for capturing all those notes, Sebastiano. And I think we have like 3 minutes left. I would like to thank all the panelists for this amazing discussion. We certainly killed some misconceptions about fuzzing, about SBST. We talked about problems and it was very insightful. I'm sure the audience really enjoyed it. And to be a little bit precise, we had 110 watchers at some point watching your discussion panel. So a really good turnout. Thank you very much. And would you like to add something else before we leave for a quick break?
This has been really exciting, and thanks for the invitation.
Yes, thank you for organizing a very interesting panel.
Thank you for setting this up, and I'm leaving less sure about the difference. So I have a lot to think about after the panel.
There's a very fuzzy line between both topics.
Yeah. Actually, me and Giovanni were a bit afraid to have this conversation, that we ended up in a fight, or actually was very constructive, very well. But we were joking about it, actually. So I think we ended up all agreeing on the same point and same direction of the community. So that's quite interesting and fun. So thank you very much for it.
Exactly. Thank you. I hope you had as much fun participating in this discussion panel as we had watching it. So thank you once again for being here. And everyone, please congratulate our panelists.
Thanks
and
a lot.
see you soon.
Thanks a lot to everyone.
Yeah.
Cheers.
Cheers. We are going for a quick 15 minutes break now, and after we're back, we're going to have the tool competition. So stay tuned, everyone. Have a nice break, and see you soon.